What's up, everybody? This is Mac Attack, and I am here to painlessly explain cryptocurrencies. If you have heard of cryptocurrencies before, but whenever you read about it or hear about it from other people, it's like they're speaking a foreign language. You have no idea what they're talking about. This video is for you. Let's get started. So these are the two big concepts I want you to walk away from this video knowing and having a pretty good idea of what they're all about. So the first idea is cryptocurrencies rely on digital scarcity, and this digital scarcity is created by decentralized computer networks. Now, don't worry, these two ideas are kind of foreign to you. We're going to really dig in deep into the details of these two ideas, and you're going to walk away with a great idea of what this means and how it relates to cryptocurrencies. The first idea we're going to dig into is digital scarcity, and we're going to do that by contrasting digital scarcity versus digital abundance. And digital abundance is essentially what we live in now with the internet. Let's pretend you have a cat picture on your computer and you want to share it with your friends. What do? You simply just send it over to them, and now they have a copy of the cat picture on their computers. And if they wanted to send it off to their friends, they could do that too. They can just send off a copy to their friends. And what we see is that this one cat picture started on your computer. You made a copy, you sent it to your friends, they have a copy, and now other people have a copy. And essentially, it's the exact same copy of the same cat picture across all these different computers. And the cost to do this was essentially free. It doesn't really cost any money to send this cat picture across the internet and to spread it across millions and billions of people. And so that's what I mean by digital abundance, is the fact that we can copy digital information and spread it to other people. But what is the downside of digital abundance? Well, the downside of digital abundance is the fact that we cannot create the sense of value or money on the internet as it stands right now. So if we take that same example, let's pretend you just have a dollar bill on your computer and you want to send it to your friends. So what you could do is just make a copy of that dollar bill, since it's just digital information, right? You make a copy of that dollar bill, you send it over to your friends. They send it over to some of the friends that they know. And so now their friends have a copy of this digital dollar. And so really what's going on here is that this digital dollar, its value would essentially be destroyed, since you can just make an infinite copies of these dollars and just send them out to anyone on the internet. And that's just not a good way to represent value. It's not a good way to represent money. It's just impossible to represent value or money on the internet as it stands today. And so that's the biggest downside of digital abundance, is that we can't create the sense of digital scarcity as it stands right now. And so what we've done to kind of work around this problem with digital abundance is we've created this idea of centralized entities. And I'm going to use the example of Venmo as the example of a centralized entity. And so what makes a centralized entity centralized is the fact that it has some sort of database or ledger on its computer. In this case, it's just a simple ledger of Bob owning $0 and Alice owning $1. And it's centralized because Venmo is the only person that controls this database or ledger on its computer, and it has complete control over this computer. And hence, that means that it's complete control over its ledger and database. And so what we're going to do is just kind of quickly go through an example of how a payment is processed on Venmo, which once again is an example of the centralized entity that I'm using. So let's say Alice has $1 and she wants to pay Bob $1. She'll send a message to Venmo, and Venmo will update its database or its ledger, and it will debit Alice $1 and it will add $1 to Bob's account. And then Venmo will send a message to Bob saying, hey, Alice paid you $1. And then both Alice and Bob's phone would update to show that their balances had been updated. And this is just a quick example of how a payment is processed through Venmo or another centralized entity. All right. So centralized entities are great. They kind of create a workaround around that problem of digital abundance. So they kind of create this, a weak form of digital scarcity, but there's some strong downsides of having these centralized entities process these payments or create that weak form of digital scarcity. So let's say Venmo has kind of gone rogue, it's acting nefarious, and we're representing that by turning its computer red. And let's say that they just change Bob's account from $0 to $9. So essentially, what they're doing is just printing money out of thin air. And they do that because they control the computer that this centralized database or this centralized ledger is hosted on. So they have complete write access to that database. And so they're able to essentially print money out of thin air and just give it to whoever they want. So they can take Bob's account from $0, they can just change it to $9 without asking anyone permission or any accountability whatsoever. Another example, let's take Bob's balance down to $0 again. Let's say Alice wants to process a payment by paying Bob $1, like we saw before. She's going to send a message to Venmo and say, hey, let's pay Bob $1. What Venmo can do is they can look at that transaction and they can say, nah, we're just not going to process that payment. And essentially what this does is it locks out Alice from the Venmo ecosystem, and she's not able to make payments to other people. And you can see how this be a big deal if Alice is trying to buy food or get to work by paying for gas in her car. Imagine trying to live your life without being able to pay other people money. That's a huge, huge deal. So you can see how this is a very big problem to have, locking people out of payment systems. The last example we're gonna use is, now let's say Venmo takes it a step further. Instead of just blocking Alice's messages on this Venmo ecosystem, they just cancel Alice altogether from the ecosystem. They just delete her. So they take away all her money. They don't allow her to process any transactions, and that completely destroys Alice's value in money and the savings that she's built up over time. All right, so now we're going to transition from centralized entities, and we're going to contrast that with decentralized networks. And so just a quick recap, we talked about how we live in an age of digital abundance, and the downside of that digital abundance is the fact that it's hard to create value or money on the internet. And so we created a workaround to get some weak form of digital scarcity in this current age by creating centralized entities. But then we kind of walked through some of the issues that we have with having centralized entities controlling these centralized ledgers or databases. And now what we're going to do is we're going to transition from centralized entities into decentralized networks. And we're going to see how decentralized networks kind of prevent some of the issues that we saw with centralized entities. But before we get into that, let's just take a look at what are decentralized networks. All right, so here we are with our Venmo example. Here's Venmo with their one computer and their one ledger on that computer. Now let's pretend that Venmo makes a copy of this ledger and puts it onto another computer. And then what they do is they link these two computers together so that these computers are sending messages back and forth. And not only do they do this once, but they keep going. They add another computer with another ledger, the exact same ledger, and they connect those computers together. And they keep going. Another computer, same ledger, distributed across many, many different computers, but all these computers are connected together and they're talking together. So this is a contrast to just one centralized entity controlling one computer. In this case, it's one centralized entity controlling multiple computers, and these computers are talking to each other, sending messages back and forth. So now let's look at how this new system would process a payment on this Venmo ecosystem. So Alice is going to send a message to one of these computers, and she's going to say, hey, pay Bob $1. And what this one computer is going to do is going to receive that message. It's going to update its database, just like we saw before, and it's going to debit Alice $1, and it's going to give that $1 to Bob. And then what it's going to do is it's going to send that message to all the computers that it's connected to. And then all those computers are going to receive the message. They're going to update their centralized ledger, and they're going to say, hey, debit Alice $1 and give it to Bob. And then that continues. So now these computers are going to talk to all the computers that they're connected with. Those computers update their ledger. And then what we see is that one message to that one computer starts a chain reaction of a cascading messages across this network until all the computers on this network have updated their ledger. And what we would see is that now Alice has paid Bob $1 since all of the computers on this network have updated their ledger on their computer. Now, let's take this a step further. Instead of Venmo controlling all of the computers on this network, you could imagine a scenario where Venmo does the exact same thing what we saw before, where they could change Bob's balance. They could prevent messages from being processed. They could just try to cancel people from this network. They can do that because they own every single computer on this network. So now let's pretend that we took that idea away that Venmo owns each and every one of these computers. We just stripped that away. We stripped that away, and instead of Venmo, one centralized entity owning every computer, what if we had individuals across the globe owning these computers with this ledger, the same ledger across all these different computers? And so what we see is there's no one entity controlling all of the computers on the network. It's broken up. The power is distributed across individuals, and these individuals are distributed across the globe. And so what we're really doing is we're creating a decentralized network of computers, a decentralized network of individuals. They're still working together. They're still talking to each other, sending messages back and forth, but it's more distributed. It's more decentralized since no one actor has control over the entire network. And now let's take it one more step further. So these computers are holding a ledger of dollars on their balance, right? So we see that Alice owns $1, Bob owns $0. So now let's take that idea away of dollars being represented on these ledgers. Let's take that away. And now let's add this notion of Bitcoin or any other cryptocurrency that you can think of. So in this case, instead of the ledgers having information about who owns what dollars, now the computers have information of who owns what Bitcoin on this network. And so right here, I want you to really take a snapshot in your mind and picture this. This is essentially the representation of almost every single cryptocurrency network you can think of and read about. It's computers located across the world, and those computers are hosted and owned by different people. And those computers hold records, not of dollars, but they hold records of their cryptocurrencies and who owns what cryptocurrencies. I'm using the example of Bitcoin since it's most widely known about cryptocurrency, but you can imagine any other cryptocurrency being used. So this right here is essentially a snapshot of what cryptocurrency networks look like. They're built on decentralized computer networks. And you might be asking yourself, well, how do these cryptocurrency networks, how do they process payments? Well, they process payments essentially like we saw before with the Venmo example. But remember, Venmo doesn't control every single one of these computers. Now it's just individuals across the globe. So let's say Alice wants to pay Bob not $1, but she wants to pay him 1 Bitcoin. So she sends a message to one of these computers on the network that says, hey, pay Bob 1 Bitcoin. So that message gets transmitted to a computer. That computer updates its database. It takes 1 Bitcoin away from Alice, and then it gives it to Bob. And now that computer sends that message onto the computers it's connected to. It says, hey, take away 1 Bitcoin from Alice, but then give it to Bob. And the same thing happens. Those computers talk to other computers on the network. And then finally, we see that all the computers on this network have updated their ledger on their computer to have Bob have the Bitcoin instead of Alice. And essentially what this happens is now anyone in the world can look at this network and say, hey, Bob owns a Bitcoin, Alice does not own a Bitcoin. We have essentially processed that transaction just like we saw before with dollars, but with this time it's with Bitcoin. All right, so now let's dig into why are we even doing this? Why are we creating these decentralized networks? They seem much more costly, right? They're much more costly. There's a lot more effort involved in creating them and maintaining these decentralized networks. So there's got to be a reason why we're doing this. So now we're going to dig into the strengths of these decentralized networks, which power these cryptocurrencies by creating that digital scarcity like we saw before. Okay, so imagine one node on this network has gone rogue, and that's that bottom left one with that red computer, just like we saw before. This computer has gone rogue. It's not following the rules of the network, and we're going to see how the network responds to this nefarious actor on its network. All right, so once again, Alice is going to send a message to this computer and say, hey, pay Bob a Bitcoin. But this computer, instead of processing that transaction, cancels that transaction. And before, what we saw with centralized entities is essentially Alice would be cut out of this network. She would not be able to process the transaction. But in this case, since we're working with a decentralized network, instead of sending that one computer the message, she can change who she sends that message to. So instead, she changes it to a different computer on the network. She sends the same transaction. She says, hey, pay Bob $1. That computer gets a message. It updates its ledger. It takes a Bitcoin away from Alice, gives it to Bob. And now the same thing happens. That computer talks to the other computers on the network that it's connected to. They update their ledger. Bob receives that Bitcoin. And then the message gets passed on until the entire network, except for the nefarious actor, of course, processes this transaction. So now Alice is able to actually pay people because not all of the nodes on this network are acting in bad faith. All right, let's add another example to the strengths of decentralized networks. Let's say that this nefarious actor just takes away a Bitcoin from Alice and then just gives it to Bob. But instead of just having that transaction stay in the computer, it needs to disseminate that transaction across the network in order for that transaction to actually take hold on the network. So what it needs to do is it needs to send that message to all the other computers that it's connected to say, hey, pay Bob 1 Bitcoin from Alice. But what's nice about this setup is these computers can receive the message. They can verify the fact that this was not started by Alice. They can see that this computer node on the network is acting nefariously, and they can take this transaction and they can just throw it away. They can cancel it. They can stop this transaction from being processed because they know it is not a valid transaction from Alice. Now, essentially what this does is it protects Alice's money on this network. Before, what we saw is that centralized entity could just change the ledger and take money away from Alice and give it to Bob. But in this case, since all of the nodes on this network need to process this transaction, and these nodes can verify valid transactions versus invalid transactions, we are protecting Alice's money on this decentralized network, which is a huge, huge strength. All right, so that's a wrap on this video. Remember, the two big takeaways that I want you to walk away from are cryptocurrencies rely on digital scarcity. And remember, we're starting with this idea of digital abundance. That's kind of the world we live in now. We created a workaround to digital abundance by creating centralized entities, but we saw there's a lot of downsides with those centralized entities. So we transform centralized entities into decentralized computer networks, and those decentralized computer networks recreate that idea of digital scarcity while still protecting people's money and their ability to make transactions on that network. So that is a wrap on this video. I really hope you enjoyed it.